we are going to finish coordinate geometry today. We have to do circles. The last thing that we did was we looked at how we can find the intersection point of any two curves on a two-dimensional plane. So when I say any two curves, the cases we considered were the intersection of two straight lines, the intersection of a parabola and a straight line, the intersection of a circle and a straight line. And in the case of two straight lines, we understood that if you think of two straight lines, they don't always intersect. Any two given lines don't always intersect. They intersect if there is an angle. If they are non-parallel, they intersect. If they are parallel, they will not have an intersection point. That's all. Those are the two cases that can happen with two lines. They will have an intersection point if they are not parallel, or they will not intersect if they are parallel. In the case of a parabola and a straight line, you can have there are three cases. You can have the line crossing through the parabola, intersecting it at 2 points, or you can have the line being a tangent to the parabola, which means it just touches the parabola at a certain point, in which case you will have one intersection point. Or else you can have the line placed on the grade in such a way that it doesn't intersect the parabola at all. So in terms of solving the equations, what happens is, when you solve the equation of the parabola and the equation of the line simultaneously, you can get two solutions. You might get just one solution, or you might get no real solutions. And then for the circle and a straight line, again, there are three cases. The line could be cutting across, cutting through the circle, intersecting the circle at 2 points. That's when you would get two solutions when you solve the corresponding equations. Or you can have the line being a tangent again to the circle. It's just a tangent to the circle, in which case you will have one solution when you solve the two equations. So one intersection point. Or you can have the line being completely outside of the circle, so that it doesn't cut the circle at all. That's when you won't have any solutions. And the most important thing that you have to understand here is how you can use the discriminant b squared minus 4ac, the discriminant, the value of the discriminant, to determine discriminant of what? The discriminant of, now when you solve either a parabola and a line or the circle and a line, those are the two things you will get. If you're solving a parabola and a line, or a circle and a line, when you solve them simultaneously, you eliminate y or x, and you obtain a single quadratic equation of one unknown. The discriminant of that could tell you, even before you complete the solving, that can tell you whether you're going to have two solutions or one solution or no solutions, no real solutions. So you can, before completing the solving process, you can predict how many intersection points the parabola or parabola and the line, or the circle and the line, are going to have. So this is the summary of what we did. Good morning, Afra. I'm just seeing your message. This is the summary of what we did last few weeks. So we already saw briefly the equation of the circle, but today we are going to learn the equation of the circle properly. Did I give you homework? So I'm very absent-minded. I hope you have figured that out by now. I think I did give you homework from the booklet. Can someone speak to me, or? Yes, right? Okay, let me go to the booklet. You tell me which ones, which questions I gave you as homework. That's not the one. That's not the one either. This is the one, right? Okay. Right. Could you drop in the text in the chat box?
Question 4 and 6.
Say that again.
Question 4 and 6.
First one, 1, 4 and 6?
4 and 6, miss.
Just 4 and 6. Okay. Let's check them out. Here's number 4. Now, the answers are at the back of the booklet. So, you know when you do it, whether you got it right or wrong. So, it's just one line problem, isn't it? But 4 marks. And see how what a simple question this is. Find the coordinates of the points of intersection of this line and the curve. Now, see, they can give you. Now, we specifically learned the intersection of parabola, a parabola and a line, and a circle and a line. But for the curve, now for the curve, the 2 cases we learned were the curve we had were a parabola or a circle. But they could give you some, we don't know, we don't even know how the curve looks like. Now when you see this equation xy equals 12, you don't know what that is. You can surely say it's not a parabola, it's not a circle, because you can identify by looking at the equation whether it's a parabola or a circle. Please remember this. When I give you the equation of a certain curve, you have to be able to identify if it is a parabola, you have to identify, this is a parabola. If it's a circle, you have to know that's a circle. If it is neither, you have to know that too. This, I don't know what this is. It's not a parabola, it's not a circle, it's a curve, but I don't know what kind of a shape it is. Because for a parabola, the equation would have a quadratic. Y equals a quadratic expression. For a circle, I told you briefly last time, you would have an x square term and a y square term. If you have those 2 terms, it's a circle. But this has xy, the product of xy, a term, the term is a product of xy. So you don't have to know the shape of the curve. It's a curve, some curve. And what you have to do is finding the intersection points. You know what to do. Whenever you are asked to find intersection points of any 2 things, you take the 2 equations and solve them simultaneously. So if you all have gotten the right answers for this, we can just move on. If not, I can do it. So can you tell me, did you get the answers, everyone? Number 4, what are the answers? Let us quickly go down and see. Should be somewhere here. Right, 1.5, 8. So there are 2 intersection points, 1.58 and 4, 3. Did you all get that?
Yes, miss.
Yes, okay. Now, if anyone did not, you have to tell me. Very good, Akitmi and Aisha, Afra. Right, so since I'm not hearing anyone saying, no, I didn't get the answer, I will move on to number 6. Let us look at number 6. 6 must be right. Somewhere here. 4, 6. Okay. The curve, again, now this curve, y equals 9 minus 6 over x, we don't know what that is. It's some curve, right? Don't worry about what is that curve. You don't have to worry about that. Some curve. And the line, surely that you know that is a line, y plus x equals 8. And they say they intersect at 2 points. Find the coordinates of the 2 points. Okay, that's pretty easy. You take the 2 equations just like before. You solve them simultaneously. You would get 2 pairs of solutions. And then, so did you all get part 1? I hope you did. Part 2, the equation of the, now this part 1 is, we call these questions standard or routine questions, because you know how to do it. When you read it, I have 2 equations, I have to find intersection points, I know how to do it. There is no extra thinking involved in that first part, and also the 4th question. Straightforward questions. But this part 2, I feel like, let us see, I think it might be something where you have to think a little bit, right? It's a novelty added to this question. The equation of the perpendicular bisector of the line joining the 2 points. Now you found coordinates of 2 points in part 1. These are the 2 points where the curve and the line intersect, right? Then they say to find the equation of the perpendicular bisector of the line joining these 2 points. The equation of the perpendicular bisector the equation of the perpendicular bisector, the equation of the perpendicular bisector A and B. The equation of the, what is perpendicular bisector of the line joining? So here's the line joining A and B. Perpendicular bisector is the line passing through the midpoint perpendicular to AB. You have to find the equation of this. This point A and point B are the 2 points you found in part 1. Those are the 2 intersection points of that curve and line. The curve and line, now you can forget. You just need these 2 points and you want to find the equation of the perpendicular bisector of this line. Did you get that? So this involves everything that you learned in coordinate geometry. You have the coordinates of point A. Can someone tell me point A and point B coordinates?
1.58.
1.5. Wasn't that the answers of number 4? This is number 6, part 2. Shall I go and check?
Sorry, Miss, I was reading the wrong one.
Yes.
Wrong question answer.
Yes.
2,6.
2,6 and
minus 311.
minus 3,11, right? Let me just quickly talk about this. Did you all get it? Did you all get this part too? Everyone?
Yes, Miss.
Yes? Very nice, because it's a nice little problem that you have to think on your own. There is no like, so this is the application of your knowledge. Very good. So you have to think, I want to find the equation of this line. The best way to write the equation of the line is using point slope form, the form that you are unfamiliar with. Point slope form, that is very useful when it comes to having to write the equation of a line. That form is very useful because the only 2 things you have to know is one point on that line and the slope of that line, which is pretty easy to find in most cases. So you have to start thinking from this line. I have to find the equation of this line. If I'm going to use point slope form, I have to know one point on this line and I have to know the slope of this line. This line is perpendicular to this little line. And I have 2 points of that line. I can find the gradient of this. I can find m of this. Then I would have the gradient of that. So slope I can find. Can I find a point on this line? It passes through the midpoint of the line joining A and B. I know how to find the midpoint between 2 points. There's a formula. So you can find this point. So point you can find, the slope you can find. Then it's just a matter of putting those 2 in the point slope form. Okay, since all of you have gotten it, I would not spend any more time explaining that. That's really good. Okay. Then let's start circles. Okay. Last topic for this is coordinate geometry is circles. Let me stay on this screen. Okay. So put the topic. This is a big topic. What was our last topic? We did points, lines, and then we did intersection between 2 curves. Today's topic is circles. So we are going to just separately learn about how we can write. A circle is a geometric object, but we can give it an equation. Equations come from algebra. This is why this is coordinate geometry. I talked about this a lot in the first lesson, on the first day of this topic. So if I show you the pathway up to here, what we learned. In coordinate geometry, we are studying about geometric objects, which are shapes, in the context of a coordinate plane. We place them in a coordinate plane And then they start to have these identities, kind of, when you take a line, it's not just a random line lying in space, but it has an equation when you place it on a grid. This is what we saw, right? So this grid is very important. And when you have a line, so we started with a line. When I say line, I mean a straight line. It has an equation. And then we already knew parabolas. That's a shape, a geometric thing. That could be given with an equation. This has an equation. This has an equation. And now the circle. So we are not learning like all different kinds of shapes that comes in geometry, but these are the kind of shapes that you come across in other practical fields. That's why we are learning about especially these. So a circle, right? Again, can be, you must be able to give it as an equation. Now I'm not going to spend time. So this is circle. So this we are right here now. We are going to learn the equation of a circle. Okay, how do we write the equation of a circle? So again, when you have the equation of a shape, equation of a line, equation of a parabola, equation of a circle, you have to know what the equation gives you. So for example, here's an example for the equation of a line. Y equals 2x plus 3. What does this equation give you? It is telling you the relationship that the x coordinate and the y coordinate of any point on this line has to hold. If you take any point on this line, the y coordinate of that point should be okay. Now, if this starts happening again, you know what this is. I think it's the IV cam that I'm using that makes this a bit hard. Okay, sorry about that. Is the recording still going? Yes. I'll tell you. I will write on the. I will write on the. Let me remove this. I think. I will use the whiteboard that comes with Zoom. Okay, so I have to write on the screen, which is not very user friendly, but let's do that because I think IVCam might get stuck again. Excuse me, sorry about that. Right. Okay, so just like that, if I quickly just go back to this. I hope this won't, because I want you to just to complete that explanation. And for a parabola, parabolic equations, the equations of a parabola has something like this. It's a quadratic, like 2x plus 1, something like that. And again, that equation is telling you what kind of a relationship the x coordinate and the y coordinate of the points on this parabola has to hold, has to satisfy. And then for the equation of a circle, we should have some relationship between x and y that tells us what the relationship between the x coordinate and the y coordinate of all the points on this circle should hold, right? Okay, so that's what we will do. I will not use this. I will go to the whiteboard of Zoom. Okay, so again, so I'm not giving you an introduction about what this equation means. You know that already. So we will jump into straight away to talking about the equation of a circle. Now, you remember that the equation of a line. Do you hear that sound?
Yes, miss.
You hear it, right? Um, I think there is some construction going on. Uh, do you hear it loud? Is it disturbing you a lot? Or is it like manageable?
Manageable.
Manageable, no? Let's just see whether it will stop. Um, when you think of the equation of a line, you saw that how we can write the equation of a line in different forms. Y equals mx plus c form, the point slope form, the standard form. There were different forms in which you could write the equation. When it comes to the equation of a parabola, again, you can write it in standard form. I wrote it in standard form there. Or you can write it in the factorized form. You can write it in the complete square form, right? So there were different forms in which you could write. Similarly, the equation of a circle can be written in different forms, and you are going to learn two forms, okay? So under circles, you put a subtopic, equation of a circle. Under circles, you put a subtopic, equation of a circle. Equation of a circle. Equation of a circle. And the first bullet point, so we are learning two forms. First form, put a bullet point. I am going to use this as my bullet point. This is called center radius form. Center radius form. Center radius form. Let us draw the grid. Let me draw a circle. Now, from the name of the form, it's called center radius form. You can guess what this form must be embedded with. If you know the coordinates of the center of the circle, and if you know the radius, the length of the radius of the circle, so three information, coordinates would have two numbers, coordinates of the center and the radius, that's one number. Three numbers, if you have these two information that involves three numbers, you can put them into this form. I will give you what that form is. So let's first draw this, so I will draw a random, let me draw it in a different color. Let me draw the circle in a different color. Say I have a circle like that. I want to move it a bit, say it's right here. So the center is right here, put a dot there, that's the center. And then let me mark the radius in a different color. Let's mark the radius in a different color, right? Let's suppose I know the radius, I know the length of the radius, and I know the coordinates of the center. Let me draw, oops, no, that's not good. I will put an arrow like that. Let's say I know the coordinates of the center, A comma B. So if you know these two information, center and the radius, center means the coordinates of the point, the center point, and the length of the radius r. If you know these two information, the equation of this circle could be written in this form. What form? This form. So let me see whether I can. The equation I will write in black. Equation, and let me minimize this. I hope you are writing with me. The equation of a circle of radius write R in red. I can't change the color of just one word or one letter in this. You write it in red. I will, whatever I put in within quotes, you write in red. You don't put quotes, okay? The equation of a circle of radius R and center A comma B, that in red 2, takes the form, here's the form, x minus A in red, put A in red to the power of 2. Now this would look horrible because I'm using y minus B squared, the whole thing squared, equals R squared. That's the form of the equation. I'll tell you, let me write it in just, let me just write it freehand. Okay, I will write it in freehand. Here's the form. The form is x minus I can't write there. I have to start writing from here. X minus A squared plus, somebody saying something, let me finish writing this and check that. Y minus B squared equals, I'm putting in red those information are, oops, let me put the square also in blue, R squared. That's the form. So it is not the IV cam that makes this stuck all the time. I did not see, somebody had dropped a message before I read it. This stopped. Can you ask me again what you wrote there? I didn't have a chance to read it. Before I read it, this got stuck and now it's gone.
No, miss, the construction noise is getting louder by the minute. That's why I would put.
Right. Okay. Let me see whether I can do something about it. Okay. Give me a moment. Let's see. I'm not sure. I will try. Okay. Okay, I'm back. And Miss, the equation looks very similar to the length equation in graphs. Length equation in graphs? Does the two equation have any sort of connection? Length equation? Oh, you mean the formula to find the length between 2 points, right? Yes, there is a connection. It comes from, now let me go, I wouldn't have that, no, now, because it, let me go to the screen. Do I have that still? What I wrote earlier? I don't think it will be there. Oh, it's blank, it's gone. So let me use the IV cam again. I ran down, so I'm panting now. Okay, so the equation was, let me quickly redraw that. So when you have, right, any random circle like that. So I didn't want to place its center at a particular special point. I just randomly, so you can have any circle anywhere on the grid, right? So that its center is somewhere. So the center coordinates were A comma B. And the radius, so I will mark it like somewhere here. Radius is R, okay? And the equation was, so if you know this radius and the center coordinates, the equation is x minus a squared plus y minus b squared. Oops, this should be equals r squared, right? I will tell you, can you try thinking about what this could, it looks, the length between 2 points, the equation of the length between 2 points. You know that for that what went on was the Pythagoras theorem. When you have 2 points, x1, y1, x2, y2, and you want to find the length between these two lines, okay, it's actually the Pythagoras theorem. You draw a little right angle triangle. When you have any 2 points, you can always form a right angle triangle, right? And then the length of this line AB is the length of the hypotenuse of that right angle triangle. So if you can figure out what these two lengths are, so this length is the difference between the y's, isn't it? That's how, so this is just y2 minus y1. And then this length is the difference between the x coordinates, x1 minus x2, or x2 minus x1. I mean, that's x2, the big number minus the small number. But then when you apply the Pythagoras theorem, you square this length, you square that length. When you square it, it doesn't matter in what order you have. That's why. So if this is d squared is equal to y1 minus y2 squared plus x1 minus x2 squared. This is surprisingly similar to that. Someone is saying something. Let me check. The radius is anyway the length of a line segment between 2 points. Am I right? Yes, you are. Okay. Yes, you are. Then where do you have a, okay. So I forgot it. See how wonderful this is. So if this is R, you take any point on the circumference. So let that be any random point, like, because it could be anywhere. It could be anywhere. I could have taken this line, and this is R. Whatever point I would take, the center is fixed. From that center, any random point on the circumference on the circle, let that be x comma y. Because I'm trying to get a relationship between for a point on the line. I'm giving the equation for this circle, right? For that red line. So, and then if you write there you can create a little right angle triangle, and this is the relationship. You are connecting, you're writing what R, how R can be written in terms of these two lengths, right? So it is actually, it comes from that. And then it gives you a relationship between the x coordinate and any point on this circle, and it connects the center coordinates and the r. Okay, isn't that great? I mean, it is the same thing. So, and this is called center radius form of the equation of a circle. So you can box it nicely, right? And let's just write a little note. What happens if your circle happens to have its center at the origin? This equation reduces to something very short. Bring the circle to the, so that its center is on the origin, so that the center coordinates are 0, 0, then a0, b0, and then this reduces to just x squared plus y squared equals r squared, whatever r is, right? So we'll just make a note of that. So put a star and write. Let's hope this will not get stuck again. Put a star and write. If the center of the circle is the origin.
Excuse me, miss.
Yes.
Miss, should we draw this triangle you drew, or?
No. I was just explaining. I was just answering your question. You, whether the center radius equation of a circle has a connection to the distance formula. But if anyone, like, you can, yes, of course. I mean, always remember. Now I give you a note. I say, okay, write this down, copy that, and I say things like that. I give you a note. But in addition to that, if you feel like, no, this is important, I should write this down, you create your own note. You write down anything now while I explain. If you feel like I just said something important and it is important to you, you write it down. This is how you would take notes at university. When you go to university, you would not be given notes, right? You take your own notes down. So go ahead. If this interests you, which it should, you should put that in a bubble and put us like a, just make it your own, and make it part of your note. It's fine. But I was just explaining. I was just answering your question. But that is additional knowledge, and that's good knowledge, nice knowledge. It would broaden your thinking. So okay, so please remember, you can add anything to your note. Things that I don't intend to, you can just go ahead and add anything to your note. So, but I would specifically say what needs to come to the note, but in addition to that, you can add anything else if you want. So put a star and write, if the center of the circle, I mean, this goes without saying, this is nothing to like say again, but it's quite obvious, but we'll write it down. If the center of the circle is the origin, which means 0, 0, then we see that the equation reduces to x squared plus y squared equals r squared. Remember, r is the radius. And if you want, what I mean is this.
Miss is stuck again.
And that was stuck for a long time, right? What happens is it gets stuck, and I can't do anything about it, even if I try to reboot or like get the what do you call it, task tab. by pressing Control Alt and L. That also doesn't come. So I have to just wait until it repairs on its own. So I don't know where the problem is, whether it is Zoom or I thought it was IV cam. It's not IV cam. Okay. Okay, let's continue without wasting any more time, isn't it? Okay, so did someone ask anything? Let me check in the chat box. We didn't have anything now. Okay, so I was just saying to accompany that little star note with a little diagram if you want. So whenever you have your center, I mean, this is not something to write. I mean, it's all quite obvious, but just so that it quickly sticks in your head. If the center is the origin, this is your equation, just x squared plus y squared and equals some number times number squared, and that number is the radius. Here's a little example just to see whether you understood this. Example, I will dictate, you write it down. I will give you two examples. Example number one, write the equation of the circle, write the equation of the circle of radius 5 and center -3, 4, -3, 4. Radius 5 and center -3, 4. Can you quickly, you just put it into the form, and now you know why that form makes sense. You saw where it came from. So that's a bonus for you. You don't have the derivation of the, so I saw you where it came from, right? That's called the derivation of that equation. You don't have that in the syllabus, but you already saw it now. So what's the equation of the circle? Example 1, R is 5, center is -3, 4. So the equation of the circle you can write as x minus -3, x minus -3, so that's x plus 3 square plus y minus 4 square equals 5 squared, so that's 25 here. Did you all get that? Right?
Yes, miss.
Yes. Okay. Example 2, another example. Example 2. The equation of a circle,
Miss, there's no need to simplify further.
No. No, so this is the, you don't have to, you can simplify it if you want. I mean, then, so the next form, which is the standard form, is when you simplify everything and bring everything to one side, it's called standard form. So it's like asking, let me show it on the side. Now, when you write the equation of a line as y equals 2x plus 3, I mean, you can change that, right? You can move the terms around and you can write y minus 2x equals 3. Is it still the same? Yes, it's the same. Or you can do y minus 3 equals 2x. It's the same thing still. Or you can do y minus 2x minus 3 equals 0. All these are the same. But this is called the y equals mx plus c form. Why have we given special names to these? Because in those forms, you readily have certain information embedded into it. This is readily the gradient. This is readily the intercept. But when you move them around, now the sign has changed. So you have to, this so -2 is not the gradient, it's 2. So keeping it in this form preserves certain information. Similarly, keeping it in this form preserves. Now, if you remove everything, you would lose this information. You would not be able to look at it and say what the center is or say what the radius is, isn't it? So that's why this is accepted form for the equation of a circle. You leave it at that form. Okay. But if you like to expand it, it's fine. Still the same. If you just expand one bracket, not expand the other bracket, still it's the same equation. But you're ruining that, nice form. Did you understand?
Yes, miss.
Okay. Example 2. The equation of a circle is, I'm giving you the equation now, x minus 8 squared plus y plus 6 squared equals 7. The equation of a circle is x minus 8 squared plus y plus 6 squared equals 7. Find the coordinates of its center. Find the coordinates of its center and its radius. Find the coordinates of its center and its radius. So what is R and what is the center coordinates? What is the radius of the circle? It's not 7.
Root 7?
Root 7, because it's the square root of this number, right? What you have here, this number is R squared. So R must be root 7. Root 7, the square root of that. It's just like here. See, this number is 25. The square root of that is the radius. We squared it to get the number here, right? You square the radius here. So this is the square of the radius. 7 is the square of the radius. Then the radius must be root 7, which is a third. Leave it like that. It's a third. And the center coordinates are
8 comma minus 6.
8 comma minus 6. Very good. 8 comma minus 6. Okay, good, great. Then let's look at the next form. So this is center radius form. Why do you call it center radius form? Because when you leave it, now, like earlier I explained for I think Afra's or Aisha's question, we leave it at this form because in that form you have the center and the radius in it. And when you look at it, you can read off that information straight away without any issue, right? So that form is called center radius form. You write the equation of a circle in that form. You don't do anything to it. You don't go and expand it. You can. It would still be the right equation, but the form is gone, right? Right. So here's the second form. So you put your next bullet point, like the heart I put earlier. It's called the standard form. This is center radius form. The next one is standard form. Standard form. So the standard form, is the standard form. It is there for all lines and curves. The straight line had a standard form. The parabola had a standard form. Standard form is when you just, expand everything out and have everything on one side. Sometimes we put the number term on one side, but the standard form is when you bring everything to one side and equal to 0. That's usually what is called the standard form. So the equation of a circle in standard form, when you want to write it in that form, just means is that same, the center radius form, you expand everything and bring them all to one side. Okay, so let's write the center radius form, the center radius form, the center radius form of the equation of a circle, the center radius form of the equation of a circle the center radius form of the equation of a circle can be turned into standard form, write standard form in red. The center radius form of the equation of a circle can be turned into standard form by removing brackets, by removing brackets and bringing all terms to one side, and bringing all terms to one side. So let's see we do that and what kind of a form we get, what kind of terms it will end up to have. So let's take the general center radius form, which is a squared plus y minus b squared. Now I'm writing the equation of a circle of radius r and center a comma b in the center radius form. Let's expand everything and bring everything to one side and see what kind of a thing we get. Is it going to get ugly? Let's see. So let's expand. So I'm turning this into standard form and I'm going to see how it looks like in the end. Okay. When I expand this, I get x squared minus 2ax plus a squared plus, when I expand the other bracket, I get y squared minus 2by, let's say 2by or 2yb, doesn't matter, 2by plus b squared, and let me bring the r squared also to this side, equals 0. Let's like rearrange this into a nice, shall we write the square forms together? So I'm going to bring the x square and write the y square beside it. X squared plus y squared. And then let me write the x. So I have an x squared term, I have an x term, this is just a number, y square term, a y term, and just a number, I'm going to write all the numbers together and the x term and the y term together. Oh, Afra, the center radius form of the equation of a circle can be turned into standard form by removing brackets. oh, Masha, I'm sorry, I didn't see your, I'm very sorry, Masha. And thank you, Afra, for taking the trouble of typing the whole sentence down. Yes. I have the chat box opened here, but it doesn't give me a notification sound or anything like that. And so I have to look at it to see whether you have written anything there. Thank you, girls. So x squared plus y squared. I'm just going to arrange them in a good order. So I will write the x term next, minus 2ax, and the y term next, minus 2by, and then a square, b square, r square, they're all just numbers. They will all blend, simplify into, if this was a real example, they will all simplify into one number, because a squared is a number, b squared is just a number, minus r squared is just a number. They will simplify into one number. So I will write them as plus a squared plus b squared minus r squared. You know that this whole thing is just one number. Okay, if I call it like c or something, because it's just a number, here's how your standard form would look like. it takes the form, it's a form, right? We are trying to see the template of it. It's like a, what do you call it, like a mold, right? Any equation of a circle could be put into that form. X squared plus y squared minus 2 some number times x minus 2 some number times y plus some number equals 0. That is, you don't have to memorize this, okay? That is your circle equation in standard form. What you have to know is, now I started with the center radius form and I turned it into the standard form. Can we go backwards? If I give you a equation of a circle in standard form, can you go back to the center radius form? This is interesting. You can do it. And that's what we are going to do next. But before that, let me write as an example. Here is an example for the equation of a circle in standard form. Example, the equation of a circle could be something like this. So here's a solid example. Okay, I mean you can write your own. So it will have this is how it will look like. It will have an x square term plus a y square term and an x term, some like minus 6x, like plus 10y, and just a number term plus what, plus 15 minus 15, I don't know, plus 15 equals 0. Right? So these terms would be It briefly got stuck, isn't it? I thought it didn't. So I think about like every 10 minutes, it's prone to getting stuck. Okay, so you have the x square term, the y square term, an x term, a y term, and a number term in the standard form. Okay. This is how, remember I told you when we were doing intersections, if you have x square and y square, it's a circle, right? You might not have these two terms, but this x square and y square has to be there. These could be 0 if the coefficient is 0, like that can happen, right? So you might not have an x term, you might not have the y term, but these two terms would always be there. Right, now let's do the reverse. Let's turn the, so these are the two forms, that's it, right? For the theory part, the equation of a circle could be written in center radius form. By expanding all of that, you can get the standard form. That's all you need to know. But in addition, let's quickly see where the possibility of turning this back into the center radius form. So just write one little, a few sentences. When the equation of a circle, oh, before that, I'm sorry, before that, why do we even discuss how we can turn this back into center radius form? Because center radius form is the useful form. In that form, you can see the radius and you can see the coordinates of the center. Can we see them now? In this form, what information can you get about the equation, about the circle? You can't see anything. It's all gone. It's all jumbled up and it's all gone. In the center radius form, they are readily there, visible. You don't have to do anything. You just look at it and you can say it. So that is a useful form, right? Just like with a straight line, slope-intercept form is useful. It gives you the slope and the intercept readily. Point slope form is useful. The slope is there and the point is visible. You can just extract that information. Standard form just loses everything, right? So that's why we are discussing that, okay? So when the equation of a circle is given in standard form, is given in standard form, little information about the circle can be directly extracted. Little information about the circle can be directly extracted. Therefore, it is useful to turn the standard form into center radius form by, I will tell you what you are supposed to do in order to do that, by completing the square for the x terms and the y terms separately. That's how you do it. So I'm saying how to do it too in the same sentence. It is useful to turn the standard form into center radius form. How do you do it? By completing the square for the x terms and the y terms separately. Then you will get that x bracket and the y bracket nicely. Okay, let's do an example. Was that sentence okay to everyone? Do you need me to repeat the sentence that we wrote? Anyone?
Yes, miss.
Yes?
Yes.
Okay, so the whole thing again. When the equation of a circle is given in standard form, little information about the circle can be directly extracted. Therefore, it's useful to turn the standard form into the center radius form by completing the square for the x terms and the y terms separately. Okay? Or one more time? Anyone? Is that okay?
Yes.
Yes, okay.
Yes.
So let's do the example. Here's an example. I'm going to start with the equation of a circle in standard form, and I'm going to get back my center radius form. Okay? Example. So the question is, turn the following equation of a circle, into center radius form. Here's the equation. X squared plus y squared minus 6x plus 10y minus 15 equals 0. Okay? We are going to complete square with the x terms and complete the square with the y terms. This number, let's take it to the other side, because in the center radius form, there is a number alone on the other side. So let that be that number. We'll see whether that would change. That would eventually change But to begin with, let's move that to the other side. And I'm going to write the x terms together and the y terms together. So that's what I'm going to do in the first step. I'm going to write the x terms together, the y terms together, and I'm going to move the number to the other side. So here I go, x squared minus 6x plus, I'm just leaving some space just for you, just so that you see them like separately, y squared plus 10y equals 15. So I have written the x terms together and the y terms together. And I'm going to complete the square for this and complete the square for that. Because I know when I complete the square, here I have x square and x. When I complete the square, I get one bracket with just one x. So I get that form, right? So let's complete the square. I'm going to put a big bracket here for this, plus and a big bracket for this. I'm going to complete the square for the two separately. So I'm going to have something square minus a number square, and again here something square minus a number square, right? So what do I get here? X, this same sign minus.
Miss, you're stuck again.
Do you see me?
Yes, miss.
But this looks stuck again.
But the cam is stuck.
Cam is stuck, huh? Yeah, let me stop sharing that. Is it still recording? Still recording. You're back with the cam? Yeah, no? Whew. Okay, right? You can hear me, you can see me, see everything?
Yes, miss.
Yes, okay. So, I went on up to that before I realized I was stuck. So, when you complete the square for these two, x minus, this is same sign here, x minus, half of that, so that's square, minus the same number square, and then here you get y plus the same sign plus half of this number 5 and then 5 square here, right? So let me write that nicely now. This is just x minus 3 squared minus 9 plus y plus 5 squared plus, sorry, it's getting stuck quite frequently now.
Yes, miss.
Yeah.
You were stuck a few minutes ago.
Minus 25 is equal to 15. So do you see I have those two terms, nice looking terms, and these two numbers I have to just move to the other side to get to the center radius form. So here is my form finally looking like this: x minus 3 squared plus y plus 5 squared is equal to, what do I get? 15 plus 9 plus 25. How much is that? 15 plus 9 plus 20. So I will straight away write, I think that is 49. See the usefulness? Now magically, not magically, we know what the magic is, but quite magically,